all the postulates that you know already. Segment addition postulate, angle addition postulate. The very first postulate, through any 2 points, there is exactly one line. Remember, postulates are accepted rules or statements that we follow in geometry. I don't have to really give you much explanation. You just look at it and it makes sense. Like if I wanted to connect that sprinkler head to that sprinkler head, which are 2 points, I could do it with a string, a line. I could connect the clock to this green magnet, 2 points, with this piece of string. I could go from the decimal point on pi over to the, I don't know, doorknob. Okay, 2 points make a line. Postulates, you just accept them. When we get to theorems, which we'll get there in this chapter, we actually prove theorems, hence why we need to figure out what a proof is first. These postulates I have listed, you'll use those as reasons in proofs, not so much today, but later on you will, so keep that page handy throughout the year, maybe put a little tab next to it or something so you know where those postulates are. At the very bottom of that first page, I have 2 different diagrams that are illustrating one of those postulates above. So that first one we have if something, then something. I don't know if you can see it on your paper, but there's supposed to be a dot where those lines are crossing, as opposed to in the first picture, the second one has a dot there. So looking at the list of postulates at the top, what postulate are we trying to illustrate there? Grant? Exactly. If 2 lines intersect, then their intersection is exactly 1 point. That's what we're trying to illustrate. You can write down so we remind ourselves. If 2 lines intersect, if 2 lines intersect, then their intersection is exactly 1 point. Jorgensen, what do we call that part that follows the word if? Good. What about the part that follows the word then? Excellent. If 2 lines intersect, then their intersection is a point. Remember, if, it's conditional, it's hypothetical, it may not always happen. Hence why it's called the hypothesis. If 2 lines intersect. What if 2 lines don't intersect? Then what? They could be parallel or skew. Good. Okay, so it may happen, it may not always. How about the second one? If something, then something, and then in the conclusion there, I'm trying to highlight that there's a line. Which of our postulates are we illustrating here? Billy? What's it say? Exactly. If 2 planes intersect, then their intersection is a line. Two planes intersect, hypothesis. Intersection is a line, conclusion. No, you don't have to. I'm just doing it up here to review. If the planes intersect. What if they don't intersect? Then what? Then they're parallel. Good. Don't flip it over. Stay on that side. We have to go through all those properties there in the middle of the page. All right. So most of our homework is going to be based off of the properties that we're going to go through now. You already know half of them, because half of them are algebraic properties. It's how you solve algebraic equations. We've already been solving equations this year. So your first one, the addition property states, if A equals B, then A plus C equals B plus C. They're adding the same value to both sides of the equal sign. It's your addition property. You add the same number to both sides, then your equation stays balanced. So like in this example, to get x by itself, we would add 3 to both sides. Addition property. Subtraction property. If A equals B, then A minus C equals B minus C. They're subtracting the same value this time. They're subtracting C on both sides. They're keeping the equation balanced. So in that example, if x plus 12 equals 24, then I'm going to subtract 12 from both sides to figure out what x is. Subtraction property. You do it to both sides of the equal sign. If you only do it to one side of the equal sign, like you combine like terms, that's called simplifying. If you add stuff to both sides, then it's your addition property. Multiplication. If A equals B, then A times C equals B times C. Now they're multiplying by the same value. So in our example, 1/2 x equals 14, we don't like to divide by fractions. We multiply by the reciprocal. Multiply on both sides. It's your multiplication property. Division property. If A equals B and C does not equal 0, then A divided by C equals B divided by C. If I want to get 12 alone, or x alone, I guess, you divide by 12. You've used these already. It's just now today when you use them, you have to say over on the right side which property you're using. Like when you use the addition property, then you'll write addition property. And at the end when you divide, you write division property. So you're actually going to have to write it down now. On this division property, it says if A equals B and C does not equal 0. Why did they put a restriction on C? Why can't C equal 0? Where's your C at? In the denominator. When something's in the denominator, what is it doing? You're dividing by that number. So why can't C equal 0? You can't divide by 0. If you tried it in your calculator, it'd shoot out error. Can't divide by 0. So they're just saying you can't do that. So never divide by 0. You've used these already. These next three, these are new ones. Maybe you want to put a little star next to them. Stars. You actually see these on your paper 2 times because you have a reflexive property of equality, equal signs, and then you have a reflexive property of congruence when you have a congruent symbol. Symmetric property of equality, symmetric property of congruence, transitive property of equality, transitive property of congruence. They work the same way, and doesn't matter what symbol is between them. Reflexive property, A equals A. 2t equals 2t. That's another example of the reflexive property. 4 minus y equals 4 minus y. It's the same on both sides. It's like you're looking in a mirror and you see its reflection. The reflexive property, reflection. It's the same on both sides. When you come up to me in class and you can't figure out what property it is, I'll probably say, it's like when you look in a mirror. And then you'll go, oh, reflexive property. Get it? Get the link? Okay. Symmetric property. If A equals B, then B equals A. Go back to elementary school, like when you're in art class. What do you think of when you hear symmetric? A line? Equal on both sides? It mirrors everything? Like, what did you make that was symmetric? A butterfly! That's what I think of every time. You take like a piece of paper and you fold it in half and you just do half the butterfly. And then when you unfold it, it's the same on both sides. What do you call that fold down the middle then? Yes! Line of symmetry. Good. The symmetric property has a line of symmetry. It's the word then. So like if you could fold the sentence on the word then, everything lines up. See, my B's would hit each other, the equal signs would hit each other, and then the A's would hit each other. So your symmetric property uses the word then as a line of symmetry. So in this little example here, if 2x plus 4 equals 8, then what? Anybody? What would have to come next so that when I folded it, it hit itself? 8. 4 plus 2x. Good. Then they would hit each other. Do you use the symmetric property just to rearrange things on the equal sign? Because what I did really in the hypothesis to the conclusion What was ever on the left side, I put on the right side, and what was ever on the right side, I just put on the left side. That's what you use your symmetric property for, just to rearrange it along the equal sign or congruent symbol. Last one, transitive property. If A equals B and B equals C, then A equals C. The transitive property gets rid of the middleman. What's in common there? So since A is equal to B and C is equal to B, well, we can just get rid of B, and A and C would be equal to each other. They're both equal to B, so wouldn't they have to both be equal to each other? Shake heads, yes. Like if angle A equals 32 degrees and angle B equals 32 degrees, wouldn't angle A equal angle B then? Because they both equal 32. Okay, transitive gets rid of the middleman. So here in our example, if 2x plus 5 equals 12 and 12 equals x plus 10, then blank. Well, 2x plus 5 is equal to 12, and x plus 10 is equal to 12. I can just get rid of this 12, instead say 2x plus 5 equals x plus 10. Transitive property eliminates the middleman. The transitive property will have the word and within the conditional statement. If angle A is congruent to angle B is congruent to angle C, and angle C is congruent to angle D, then I'm able to say A is congruent to D, because they're all congruent to the ones in the middle, so the ends have to be the same. Transitive. Cool. Next two, we've already done a bunch this year. Substitution property. If A equals B, then B can replace A in any expression. So if x is equal to 6, I can substitute 6 in for x, and then it would be 3 times 6 plus 12. We've done that. You did it on your test last week. You did it on your quizzes. Substitution. Same with distributive. A times the quantity B plus C is the same as saying AB plus AC. So here, instead of saying 3 times the quantity x minus 14, we could just say 3x minus 42. Okay, so when you're using these properties today, you have to tell me how you do it. Capiche? Gosh, cool. The reflexive, symmetric, and transitive properties of congruence work the exact same way as they did in equality. Angle A is congruent to angle A. It's the same angle. It has to equal itself. If angle A is congruent to angle B, then angle B is congruent to angle A. Symmetric property. If angle A is congruent to angle B and B is congruent to C, well, we can just get rid of B and say that A and C are congruent. Capiche? Cool. Now you can flip it over. We're going to skip that top example with the planes. And we're going to number 1 where it says justify, blah, blah, blah. Okay. Proofs in geometry. There's many ways you can write a proof. There's things called flowchart proofs that have like all these bubbles all over and you're supposed to follow the arrows and they float around. They get super confusing, so we don't use those. Then they have paragraph proofs where you actually write out a proof sentence by sentence like an English paper. They can be as long as a page or two. We don't do those either. We do 2-column proofs. So all your proofs this year, regardless if they're algebra or geometry, will be 2 columns. The left column are your statements or the work, and then the right side is your reasons, like where you'll list your properties today. Next week and the week after and the week after, you'll start putting theorems over here. But this has to be your reasoning why. 2 columns, left side work, right side reasons. Your first one, justify each step used to solve 5x minus 12 equals 32 plus x. Your first step in a proof is always what was given to you. So I took this equation that I gave you and I already typed it back in there for you. Our reason for that, given. Number 1 reason, given. Always, no matter what type of proof it is, if it's algebraic or geometric. Now we just have to go through and figure out how they solved this equation, how they got x to equal 11. So from step 1 to step 2, we had 5x minus 12 equals 32 plus x. How do they get down here and say 5x equals 44 plus x? Added 12. Good. You add 12 to both sides. So then this is your addition property. From 1 to 2, we use the addition property. From 2 to 3, 5x equals 44 plus x. Now it's 4x equals 44. Yeah, they subtracted the x on the right side over to the left side. When I do it on both sides, then that's called your subtraction property. And then from 3 to 4, 4x equals 44, x equals 11. Yeah, they divided. They divided both sides by 4. So then this is your division property. That wasn't so terrible, was it? No. I mean, I did all the work. You just had to figure out what I did. Maybe that's more hard than doing the work yourself. What do you think? I don't know. Okay. You'll have 4 of them like this on your assignment today. I call these fill-in-the-blank proofs because I already did all the work. You got to fill in the reasons. I call those fill-in-the-blanks. So you have 4 fill-in-the-blank proofs. Second one. There's going to be 5 steps to this one. So those of you that write big, don't write too big. Sorry, I didn't give you a lot of room there. Our first step is what's given to us. So you take what's behind the word given and copy it down into step 1. Negative x minus 2 times the quantity 9 minus 8x equals 12. Reason given. We're trying to prove that x equals 2. So we already know what the final answer is, x equals 2. What I'm after today is how you get there. And if you can tell me your reasoning why. Not so much what x equals 2, like what that answer is, just how you would get there. So we have to think, what's our first step here? What do you want to do? Trinity? Distribute what? Distribute the negative 2, so then what's that next line going to look like? Good. Distributes, and then step 2, distributive property. If you want to color code yours, if you have like colored pencils or pens or something, that might help you too, as I'm doing it. Whatever makes more sense to you. Okay, what would we do next to get x by itself? Trinity? Add like terms. So what terms are we going to combine? And that would give me what? Good. So 15x minus 18 equals 12. Trinity, did you add on both sides of the equal sign? Did you subtract on both sides? Okay, so that's not addition nor subtraction. So I didn't do it on the left and right side. But you said combine like terms. So you could write that down as your reason. Or this is called simplifying. When you stay on one side of the equal sign, it's simplifying. So you could write simplify, or you can write down combine like terms. Whichever makes more sense to you. It's only addition when you put it on both sides. Okay, next step to get x alone. How about someone other than Trinity this time? Add 18, good. If I add 18 to both sides, then I get 15x equals what? 30, good. And I did it on both sides of the equal sign, so now we can call it the addition property. Last step. Divide by 15. What's 30 divided by 15? Is that what we wanted it to equal? Nice. Division property. So when you're doing proofs, you will always know what your final answer is supposed to be. You just have to figure out how to get there and explain why. You can't skip steps in a proof. So a lot of you mentally would probably combine like terms in your head, but today you have to actually write that down and tell me when you do it. Or you might combine like terms and add 18 at the same time. You can't do that. Can't combine steps. You got to do it one by one by one by one. All right? I know it'll get a little tedious, but we'll get there. Questions on this proof? You have 3 of those. today, where you have to do them all by yourself, the left side and the right side. The rest of your worksheet is the rest of that side of the paper, number 3, where we have to name the property that justifies each statement. You have like 8 to 10 of these on your quiz on Thursday, and in the past, students get them wrong because they read backwards, meaning they go from conclusion to hypothesis. You have to think, how do we go from the hypothesis to the conclusion? What did they do to get there? So on this first one, if x equals y and y plus 4 equals 3x, then x plus 4 equals 3x. We have to figure out what they used or what they did with the hypothesis to get to the conclusion. And it's going to be one of those properties on the front side that's in those rectangular boxes. You're trying to figure out what's different. How did they change the hypothesis to the conclusion? What did they use? What did they do? Any thoughts? Trinity. They plugged in the x for y. Because y is equal to x. What's that called, that plug-in property? Substitution, good. This would be your substitution property. Awesome. Not transitive. Like, I know I told you that transitive property has the word and in it. That doesn't mean every time you see the word and it's transitive. It just means if you're going to say transitive, you better have the word and in that conditional statement. Not transitive there. B, if x plus 4 equals 3x, then 4 equals 2x. How do they go from the hypothesis to the conclusion? How did they make that 3x into a 2x? That's what's different. How did they do that? Did they subtract the x over? And they did it on both sides? So what property is that? Subtraction, good. C, if angle P is congruent to angle Q Q is congruent to angle R, and angle R is congruent to angle S, then angle P is congruent to angle S. What property do we have here? P and R are both congruent to Q, so I can just eliminate that. Well, P and S are now both congruent to R, so I can eliminate that. And then that leaves me that P congruent to S. Good, this is your transitive property. D, segment XY is congruent to segment XY. Everybody. Reflexive, good. Reflexive property, that's the best one. E, measure of A equals 45 and 45 equals a measure of B, then the measure of A equals a measure of B. I can cross out the 45s, so what would that one be? Could also be substitution. If your brain wants to read it like A equals 45, so I could substitute A in for the other 45, you could also call that one substitution. This one actually would have 2 solutions. I would accept either of them. Some people see substitution better than they see transitive. F, everybody. Reflexive. AB equals AB, reflexive. Notice the reflexive property has no if or then in it. It's just T equals T. Whatever it is equals itself. There won't ever be an if or a then. G, if the measure of angle ABC plus 40 equals 85, then the measure of angle ABC equals 45. How did they go from the hypothesis to the conclusion? Subtraction. They subtracted 40 from both sides. This is one that on the quiz people read backwards and they think addition, because they go conclusion to hypothesis, and then they think, oh, they added 40. No, no, no. Got to go from hypothesis to the conclusion. H. If k equals m and k plus w equals 12, then m plus w equals 12. What do you think? It's substitution. In order for it to be transitive property, you would have to have it say something like if k equals m and k equals w plus 12, so that the k's were by themselves, then it's transitive. But my k value is connected to a w, so I can't call that a transitive property. Whatever you're eliminating has to be by itself on the equal sign. Does that make sense? Just shake your heads yes for me. Thanks. Last one. If B is in the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. It's not a property, it's actually one of your postulates. Which of these postulates? What? Yeah, because Grant, what math operation are you doing? And what kind of things are you adding together? Good. To illustrate it, here's angle AOC. Here's point B in the interior of it. The measure of angle AOB plus the measure of angle BOC would equal the measure of angle AOC, the whole thing. Angle addition postulate. Good. All right.